All right, so we're back. Now what I want to do is another one. We're just going to use UI, EI, EG, and UG. And then, like I said, the following two videos from this will introduce CQ. But in this case, what I want to do is do a proof that uses existential instantiation and existential generalization, since in the previous one we just did UI and UG. So let's look at our problem. Premise 1 says for all x, if x is A or x is B, then x is C. Premise 2 says there exists an x such that that x is A, and my conclusion tells me that there exists an x such that that x is C. So let's talk strategy for a second. How am I going to get to this CX? I look over here in my premises and I see that I have a CX right here as the consequent of this statement, okay? So I know that if I can isolate this, in other words, if I can remove my quantifier, which we already know we can do via the rule UI, then I can get just this conditional by itself, and then I know if I can get AX or BX that I can use modus ponens to get CX. So now that I've figured out how I'm going to do all that, I realize that I need to use my rules of instantiation. So I want to talk about something real quick. Hopefully you're familiar with this by now, but remember our rule existential instantiation tells us that when we remove an existential quantifier, as we're going to do on line 2 to line 3, that I have to change my variable to a constant, okay? And when I change my variable to a constant, it's got to be one that is brand new. It cannot be a constant that's been used in any previous line, nor can it be a constant that's in my conclusion. Now, in this case, we're lucky because we don't have any constants anywhere. Everything's a variable. Remember what our variables are, lowercase x, y, and z, okay? So I've got the variable x in play in all of my statements up here, and no constants whatsoever. So I'll be free to use whatever constant letter I choose to use. So in this case, let's just use m for no particular reason, but I'm going to use m just because. So we get that from 2 EI. Now something else I want to talk about. Notice that in order to complete the problem the way that we worked it out ahead of time, we are going to need a UI line 1. The reason I use EI line 2 first is that if I were to UI line 1 first, then I would not be able to use the constant that I'm going to replace these variables with in my EI. So let me show you what I'm talking about. At line 4, we're going to UI line 1. And I'm going to use the same constant I used in line 3 because it's going to make my life a lot easier when it comes time to use my rules of implication. So I'm going to use m as well, because remember UI I can go from a variable to a constant if I choose to. All right, and this will be from line 1 UI. Now what I was talking about just a moment ago, had I done UI first and used this letter m, I would not be able to use my constant m when I EI'd because it would not be new. It would have already occurred in the proof. So a good rule of thumb is that when you know you've got to do both EI and UI, especially when you're ultimately going to have to use the statements that you, the statement functions that you produce after doing your instantiation, then you should always do EI first. That way, you can use the same constant in the statement function with your UI and therefore use your rules of implication with it. Again, had I done UI first on line 3, I would not have been able to do the EI with the same constant, which of course would have produced problems for me. So the easiest thing to do is just do your EI first, then do your UI. Now hopefully you can see where we're going to go from here. It says on line 4 that if m is A or this should say B. Apologize for that. That was a mistake. Again, when I remove my quantifier here, my predicate letters remain the same, but I changed my variable to the constants. So this should say if m is A or m is B, then m is C. Now I notice on line 3 I have m is A. So we can just use our easy rule of addition here. And I can just add m is B to my m is A from line 3. Okay, so I get line 5. M is A or M is B by adding to line 3. Because remember, on line 3, it's telling you I have an M that's A. So if I have an M that's A, I have an M that's A or anything else in the world, basically. So we add our M is B to that, and now if we look at 4, you'll see it claims if M is A or M is B, then M is C. Well, I tell you on line 5, M is A or M is B. Therefore, we know M is C. That's from 4, 5, modus ponens. Now the only thing left for me to do is to generalize this. Notice my conclusion says there exists an X such that X is C. So in other words, there's at least one thing in the universe that's a C. Well, right here I'm telling you M is C. So we know that there's at least one thing that exists in the universe that's a C, and that for sure it's M. There might be other things that are C's, but in this case we know that M's a C. So we can just do our existential generalization on this. And when I do that, I take my constant and I change it to the variable that is inside my quantifier. That's from 6 EG. Line 7 matches up with my conclusion. Problem solved. Again, the lesson to take from this particular example is that when you know you've got an EI and UI, you should EI first. That way you know that you're free to use your constant. Had I done it the other way around, I would not have been allowed to use M as my constant in EI, and then I would have never been able to do my modus ponens that I did. Okay? So I hope that this helps you guys get an idea of what's going on with the predicate logic. Good luck.